welcome my dear students. Today we are going to discuss some different types of problems. Under that, the first problem is a survey of 500 television watchers produced the following information: 285 watch football, 195 watch hockey, 115 watch basketball, 45 watch football and basketball, 70 watch football and hockey, 50 watch hockey and basketball. 50 do not watch any of the three games. How many watch all the three games? How many watch exactly one of the three games? Right? This is the problem we have here. Right, my dear students, here. Okay, in that part we have another problem also, that one by one we will be discussing. Like in a survey of 500 television watchers. See here, this first problem. We have 500 television watchers. That means n of u. N of u is equal to 500. Right? Very good. And 285 watch football. N of f is equal to, you have here 285 football. Next, n of h. N of h is equal to 195. You have like this. Next, basketball. Right, the basketball is nothing but 115, like this. Right, 45 watch football and basketball. N of football and basketball, f intersection b, is equal to 45, like this. Right, and 70 watch football and hockey. Football and hockey is 70, like this. Right, 50 watch hockey and basketball. Hockey and basketball is what? 50, like this. 50 do not watch any of the three games. Okay, that means n of f union h union b whole complement. Right, they do not watch any of the three games. That is equal to 50. We have here the information. Right, now what do you want to, how many watch all the three games? This is what our information. See my dear students, nicely we can do this with a Venn diagram like this, you see. Okay, fine. We have here like this three sets which indicates three games like this. One is football, one is football. Okay, n of f like this we have here, of course. Football is equal to, you have here 285 here, like this. 285, and n of mu. Actually, n of mu is equal to, you have 500 here, like this. Totally 500. N of h, this is what h. N of h is equal to, right, 195 you have here, like this. N of b equal to, now n of b is equal to, right, 115, like this you have here. Like wonderful. Like now n of f intersection b. F intersection b is equal to 115. Now, actually, how many players will watch all the three games? That is what first one we want to find, and we don't know that. Let us take that as x. Okay, first one what we require to find is how many watch all the three games. That we don't know. That we will take it as x. The first one, how many watch all the three games? Right? How many watch all the three games? All the three games, like this. Now, okay, let us get this thing very beautifully, my dear students. You know that, 50 are lying outside. Okay, this is for your kind information. Like 50 is lying outside because 50 players, the 50 persons, they won't play any game. That's why that is lying outside of it, like this. Now, let us take this f union h union b. This is equal to n of f plus n of h plus n of b minus n of f intersection h minus n of h intersection b minus n of f intersection b, like this, plus n of f intersection h intersection b, like this. Right? Wonderful. Now n of f union h union b, my dear students, you see here. Okay, n of f union h union b is actually 50 students are not at all playing any game. Therefore, 500 minus 50, that is nothing but 450. I think you will be getting this. N of F union H union B equal to 450. That because 50 are not playing any of the game. That's why we have got this thing. Now this is equal to N of F. N of F is nothing but 285 plus 195 plus 115, right, minus we have here 45 minus 70 minus 50 plus x, like this, right, my dear students. This is what we have got. Now let us try to simplify this and get x value. Now all simplification of this part will give you 450 is equal to this all simplifying, right? Okay, by adding 285 plus 195 plus 115 we got 595 minus these three things, 70 plus 50 120 and 165, that if you do 430 we have got like this. Now from this x is equal to, we have got 450 minus 430, like this, that is 20. Therefore now first one you have got very beautifully, all the three games were played by 20 people, like this. All the three games were, now here x value is equal to what now? 20 you have here, like this. Now see beautifully, once you got 20, you know my dear students, N of F intersection B, here F intersection B. F intersection B is 45, means already 20 is there, therefore it becomes 25. Because F intersection B part is this total part, that means 20 already there, means 25 you are having. F intersection H is 70. 70 means already 20 is there, means here 50 you will have, because F intersection H is this total 70. Already 20 is there, therefore that will become 50. You have next H intersection B. H intersection B is nothing but 50. Already total you have here 20, therefore you will have here 30, like this, right, my dear students? 30 you have got here, like this. Wonderful. Now the second thing what they have asked in this particular problem is, first one is how many watch all the three games, and the second one what they are asking is in this okay, how many watch exactly one of the three games. Okay, how many watch exactly one of the three games. Okay, number of persons watch one of the three games. One of the three games, right? Now only football, that means only football. Number of persons watch only football. You see my dear students how beautifully we will get. Here we write here number of students watch only football, right? Watch only football. Here see number of students watch only football. Let us what do totally 285. This part will indicates that the number of persons students will watch only football, means actually you know 50 plus 20 70, 70 plus 25 95, 285 minus 95, that will give you, that is give you 190. This will be 190 students will watch only football, right? Number of students watch only football is 190. Number of persons watching one of the three games, means this is what. Next, number of students watch only, okay, hockey. This if you take hockey, like this, right? Hockey means my dear students actually 50 plus 20 70, 70 plus 30 100, total 195 is there. From that 100 if you subtract 95 we are getting here. Of course they watch only hockey is 95. They watch only hockey is 95. We have got beautifully, right? Next, number of students watch only basketball. Now see here basketball we have here, like this. This basketball my dear students actually 25 plus 20 45 plus 30 75, 115 minus 75, what we are going to have 115 minus 75 my dear students 40. Okay, 40 students will watch only basketball, right? We have got now the students will watch only one of the games. Football only 190, hockey only 95, basketball only 40 students. Number of persons watch one of the three games. One of the three games means like this we have got. If they want the total, you can sum it up and you will get the answer. Like this, this beautiful problem can be okay answered. Next we have another problem, my dear students. In a town of 10,000 families, it was found that 40% families buy newspaper A, 20% families buy newspaper B, 10% families buy newspaper C, 5% families buy A and B, 3% buy B and C, and 4% buy A and C. Right? If 2% families buy all the three newspapers, find the number of families which buy number 1 A only, number 2 B only, number 3 none of A, B, C, like this. You see, my dear students, let us discuss this with a nice Venn diagram. Let us do this problem very nicely. You see, here we have here three newspapers here like this. We have here three newspapers like this, right? This is A, this is B, this is C. We have here like this, totally A, B, C. These are the three newspapers we are having like this, right? Wonderful. Once we have got these three newspapers, my dear students, what we have is, okay, the total n of mu is equal to, total how many members you are having is 10,000 you are having like this. 10,000 you have here. Found that 40% families buy newspaper A, like n of A, okay, 40%. N of A equal to 40%. N of B is equal to, now 20% families buy newspaper B, 20% is this. N of C is equal to, now you have here, okay, 10% paper C like this, 10% paper C like this, okay. That's nice, of course. Now 5% family buy A and B. Now N of A and B, N of A and B will give you, now what, how much now? 5%. This is what? 5%. N of, next we have 3% B and C. B and C will give you now 3% like this. Next N of A intersection C, this is equal to, A intersection C will buy 4% like this, right? Very good. And 2% family buy all the three newspapers. N of A intersection B intersection C, okay, will 2% will buy all the three games like this. Find the number of families which buy A only, B only, none of A, B, C, like this. This is the problem, my dear students, we are having here. Now U is equal to, totally how we are going to proceed this problem is, this is 10,000 actually. This is 10,000. And now A is 40%. The total means 40 by 100 into 10,000 like this. Into 10,000. These two zeros will cancel. 40 into 100. This is now 4,000 you have here like this. Right? Now this is 20%. 20% means 20 by 100 into 10,000. Now see, you have here 2,000 like this. This is 2,000. Now 10% means what? 10, okay, 1,000. This is 500. You can easily calculate. This is 300 like this. This is 400. This is now 200 you have here like this. Such a beautiful way we have got these numbers now, right? Now let us say A is equal to, we have here 4,000 like this. This is what? 4,000, N of A. N of B is equal to, here you have here now 2,000. N of B is equal to 2,000 in this thing. And N of C is equal to, N of C is equal to 1,000 like this. Right? Now all the three games were played, okay, sorry, all the three newspapers were bought by 200. This is what actually 200 you have here like this, right? My dear students, that in between part what you have here, that is what 200 you are having here like this. This is what I am writing here. This is right actually 200. Okay, here I am writing this part is 200 because there is that space is not sufficient. That's why I written here, of course. This is 200. N of A intersection B is 500. Already 200 is there, therefore it becomes 300 like this. Okay, because it is 500 means already 200 is here. 300 plus 200 that become, okay, 500. And N of B intersection C. B intersection C, already 200 is here. Here you will have here 100 here like this. N of A intersection C, 400. That means already 200 is there. Here you will have 200 like this, right? Wonderful. Now all these things very interesting now. Okay, the first question what they have asked is number of persons who will study only, find the number of families which buy only A. Number of families which buy only A is nothing but this is the part, my dear students, this is the part, only A is, this is the part, you have this kidney shape like this. Okay, that how you will get 4000 minus, right? Okay, this one 300 plus 200, 500 plus 200, okay, 700. 4000 minus 700, that is nothing but 3300 you are going to get. Okay, and one more thing, my dear students, here they have given that right, fine. Okay, this is what 3300 we got beautifully like this, 3300. Next, second one, number of families which buy only B. Number of families which buy only B. Only B is nothing but, my dear students, this is the part what we need to get this, of course. This is the part only B. Already 300 plus 200, 500 plus 100, 600. 2000 minus 600, this become 1400. Okay, only B is nothing but we have here 1400 like this. Okay, now we will get number of families which buy only C. You can take only C means nana, this is the part you are going to get like this, only C part. Already see, this is actually 200 plus 200, 500, sorry, 200 plus 200, 400 plus 100, 500. 1000 minus 500 is 500 here. You got now this is equal to 500. Now at least all the, now fourth one, all any one of the three papers, any at least one of the three papers, at least one of the, okay, three papers. At least, and that means either A or B or C were studied by this formula. We are going to get this formula. What is that formula? N of A union B union C. N of A union B union C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of C intersection A plus N of A intersection B intersection C like this, right? Very good. N of A union B union C. Okay, my dear students, what we are going to get, how we are going to get this N of A. N of A is what actually have got 4000 here, of course. This is 4000. N of B, this is 2000 here like this. N of C is 1000 here like this minus N of A intersection B. N of A intersection B is 500 minus N of B intersection C, that is 300 minus 400 plus 200. This will give you, okay, N of A union B union C like this. This is what here we have here 4000 plus 2000, 6000 plus 1000, 7000 we have here like this. Minus here 5000, 500, 800, 800 plus 1200, minus 1200 plus 200, minus 1000, then minus 1000 we have here. That means you have got nicely 6000 families they may read either, right? 6000 families they may read either A or B or C, right? They may read either, right? Either A or B or C, anything. 6000 families will read. Now, the families which you are not studying or not reading any paper. Now, the fifth one here, there is space there. I will answer here. Okay, that is nothing but N of A union B union C whole complement. This is nothing but N of U minus N of A union B union C like this. Right, N of U is nothing but what, Nana? 10,000 here like this. 10,000 minus 6,000 like this. This will give you 4,000 family members are not buying any of the newspaper, either A or B or C. In this beautiful way, we have got this particular problem, my dear students. Once we draw the Venn diagram like this, this problem becomes very easy and we will get a lot of information from that. We have answered now 5 questions for this, right? Like this we will answer this particular problem. Now we have the third problem, my dear student. The statement is two finite sets have m and n elements. Then total number of subsets of the first set is 56 more than the total number of subsets of the second one. The values of m and n are what? See, this is a nice problem. Two finite sets have, say if the first set is n of a, it is having m elements like this. And the second set is having n of b, that is n elements. Then the total number of subsets of the first set is 56 more than the total number of subsets of the second set. That means 2 power m is the total number of subsets of the first set. That is equal to 56 more than the total number of subsets of the second set. Then now we have 2 power m is equal to 56 plus 2 power n. That means now 2 power m minus 2 power n is equal to 56. We are having like this 2 power m, right, my dear students? How see what we are having like this, right? 2 power m minus 2 power n is equal to 56 like this. Now we need to satisfy m and n values. These two things you can guess that what will be satisfied for this. Let us observe. Now see, 2 power m minus 2 power n is equal to 56 means now if I take 2 power 6 minus 2 cube, that is now 2 power 6 is what? 64 minus 8, that is equal to 56. Okay, wonderfully it is satisfying. Now m is equal to 6, n is equal to 3 we have here like this. The values of m and n are 6, 3 respectively like this, right, my dear students? Like this beautifully we will get this particular problem. Now see this problem, this very simple and basic problem, my dear students. Here the fourth problem, a and b are two sets such that they given that a union b equal to a. Then find a intersection b. You see, my dear students, a union b equal to a, when it will happen actually? You see, a union b, a is this set, when b is subset, right? Now see, when b is subset of a, when b is subset of a, then only you will have a union b. A union b is equal to a like this. When b is subset of a, then when b is subset of a, now a intersection b, because right, when b is subset of a only, you will have a union b equal to a nana here like this. Now a intersection b, when b is subset of a, b is present totally within a. Now the common elements are nothing but only b. The common elements are nothing but only b. Therefore a intersection b is equal to b is the correct answer for this. Now see another important, very important star marked problem, my dear students. This, right, this star marked problem. What is this? Suppose a1, a2, a3 so on up to a30 or 30 sets each having 5 elements, and b1, b2 so on up to bn or n sets each with 3 elements. Now they given that union I is equal to 1 to 30 ai, this is equal to, okay, union j equal to 1 to n of bj, right, this is equal to s they given, and each element of s belong to exactly 10 of the ais and exactly 9 of the bj's. Then n is equal to what? Okay, they told that each element of s belongs, right, belongs to exactly 10 of the AIs, 10 of the AIs, right, and exactly, okay, each element of S, now each element of S belongs to exactly, right, 9 of the BJs, 9 of the BJs like this, right, wonderful. Then n is equal to what? That is what we require to find, my dear students. Here how we will do this particular problem. Here union I equal to 1 to n, this meaning is, instead of writing, actually this meaning is a1 union a2 union a3. Actually the meaning of this I is equal to 1 to 30, okay, so on up to union a30, this is equal to, right, and okay, this is equal to, they given that j is equal to 1 to n. union of 30 sets this. This is now union of n sets Bj. That means B1 union B2 union B3 union so on up to Bn like this. This is given as yes. This both are equal to S. Now they given that, my dear students, here in this problem they given that 30 sets each having 5 elements. These are 30 sets each having 5 elements. Therefore 30 into 5, 150 elements you are having here. And this is equal to, now what they have given that 5 elements, and B1, B2, B3, Bn are n set each having 3 elements. These n sets union having 3 elements each. That means 3 into n elements we have here like this. Right? Now we need to find, right, my dear students, okay, 3n is equal to like this we have here. One more info, this is equal to actually yes, we have like this. Okay, and one more information here, okay, 3n, this is what we are having here like this. One more information is here. What is that information is, they told that 150 is equal to 3, okay, and this information what they have given is, and each element of S belongs to, right, n sets, and B1, B2, Bn are n sets each have 3 elements like this, right? Wonderful. Now we need to find n, and one more thing they given that each element of S belong to exactly 10 of the AIs. That means A1, A2, A3 up to A10. In 10 sets the elements are repeated. The elements are repeated means they will be taken only once. That's why we are dividing by 10, like we are dividing it by 10, okay, because in 10 each of the elements of S belongs to exactly 10 of the AIs, means A1, A2, A3, A4, A10, those elements are repeated. Repeated means we have to divide by 10 because we have to take only once. And 9 of the BJs, okay, each element of S belongs to exactly, okay, 9 of the BJs. In 9 sets of B1, B2, B3 so on up to B9, those elements are repeated. That means you divide by 9 here like this. That means you have what now, my dear students, here, okay, 150 by 10 is equal to 3n by 9 we have. Let us simplify, 3 1s, so 3 3s here. See, now from this you do cross multiplication. If you do the cross multiplication, you will get n is equal to 45. This is the value you will get beautifully by satisfying all these conditions, my dear students. Right? I will repeat once again this. How you got 30 into 5 means, because this is having each having 5 elements. That's why 30 into 5. This is having each one 3 elements. 3 into n, that equal to S. Now, and they given that each element of S belong to exactly 10 of the AIs. That means you divide by 10. And 9 of the BJs divided by 9, that equal to S. Now 150 by 10 equal to 3n by 9, Nana. Now 3 1s, so 3 3s, so 0 0 cancelled, n by 3 equal to 15, n is equal to 45. That in such a beautiful way we will be getting this problem, my dear students, right? See, this problem, very important problem. Already we have discussed this in live classes. Okay, this is what they have given: n of u equal to 60, n of a equal to 21, n of b equal to 43. We need to find least value of n of a intersection b, greatest value of n of a intersection b, greatest value of n of a union b, least value of n of a union b, like this. Right? For this, how we will do this, my dear students? You see, okay, Nana? You see, first of all, okay, when we have least value of n of a intersection b. Okay, when we will have greatest value of n of a intersection, all these, okay, I may not follow 1 2 3 4 order, I may follow anything like that. Okay, first I want to find the third one, greatest value of n of a union b, right? Greatest value of n of a union b. The third one, if I want to get first one, okay, see this one, greatest value of n of a union b. Okay, when a union b, n of a union b will become greatest means when they are disjoint like this. When they are disjoint, then it becomes greatest. But is it possible that it becomes disjoint here? Okay, it is not possible here, because when they are disjoint means you have here 21 plus 43. 21 plus 43 will become how much? 64. But the universal set itself, you are having 60 elements. Any set supposed to be subset of the universal set. U itself, you are having 60 elements. That's why, okay, no. Now the greatest value of, the greatest value, because any set is subset of U. Therefore, n of A union B greatest value is number of elements in the universal set itself. That means n of U, that equal to 60 only, like. Okay, here the possible case is, my dear students, 60 only it can have the maximum number of elements. That means it is having some overlapping like this. This is A and this is B. How many elements are common means something like 4 elements are common. Okay, such that it is equal to universal set. Some 4 elements are common for this. Like this, this third one will be answered like this. Right? Fine. Now we need to get least value of n of A union B. When we are going to get least value of n of A union B, that means, my dear students, when one set is subset of another set, here n of A is 21, n of B is 43, and one set is subset of another set like this. See, A you are having 21, this is what set A. Okay, B is having how many elements? So 43. When one set is subset of another set, suppose here A is subset of B, then you have here n of A union B is equal to, right? When A is subset of B, you know that A union B is nothing but B only. Okay, that is equal to n of B, that is nothing but 43. Therefore, the least value of n of A union B is nothing but 43. When A is subset of B, then only you will be having least value for n of A union B. That is nothing but you will have 43 elements are present in the A union B, and it is the least value of it, right? Because when one set is subset of another one, then you will have least. When they are try to be disjoint, then you will may have greatest, like that. Now the second one, my dear student, greatest value of n of A intersection B. Now we have discussed that when it will have greatest maximum value for intersection means when one set is subset of another set. Here A, you have here 21 elements n of A, right? N of B, you have here 43 elements. Like this. That means when A is subset of B, A intersection B is nothing but A itself. Therefore, n of A intersection B is equal to n of A when A is subset of B. Then the greatest value of n of A intersection B is nothing but n of A. N of A is nothing but what here? 21 elements we are having here. N of A is equal to 21 elements we are having like this. Right? Now the first one we want to find least value of n of A intersection. When the least value, okay, that means in the first problem we have did that, we have here 4 elements actually. Okay, the least value is nothing but actually when you are going to get this is 4 elements and mu is equal to, we have here 60 elements here, right? The least value of n of A intersection B. Okay, when A union B is greatest, like n of A union B become greatest, that means what we are going to have, total elements, you have n of A union B when they are disjoint, that means n of A plus n of B. Okay, from this that means you have here 21 plus 43, 64. From the total elements you subtract the greatest value of A union B, greatest value of A union B, that is 60. That means 4 elements are common. As I told you, 4 elements are common for this. Then you have here n of A is equal to 21, n of B is equal to 43. Okay, 4 elements are the least possibility it is having. Okay, 4 elements will be the least of the least they should have common. Otherwise, this is not possible. Okay, because the maximum value of n of A union B itself 60. Okay, that is what universal set. And they given that n of A, n of B, n of A plus n of B, they cannot be disjoint. That means there is some minimum overlapping. That minimum overlapping means minimum of A intersection B. That is 4 is possible like this. Right? In this beautiful way, we will be answering these problems. Now see, my dear students, another interesting problem we are having here. In a mathematics class, 20 children had forgotten their rulers. 17 had forgotten their pencils. Go and borrow them from someone at once, said the teacher. 24 children left the room then how many children had forgotten both? You see, my dear students, we'll take here number of children had forgotten their rulers. N of R will indicate number of children forgotten their rulers. That is nothing but 20. Okay, N of now 17 had forgotten their pencils. N of P is equal to 17, like this. And go and borrow them from someone else, means the 24 children left the room. That means either rulers or pencils. Okay, either rulers or pencils or both are forgotten by how many students? R union P. That is given as 24 students left it. Now they are asking here how many children had forgotten both. Now we need to find R intersection P, my dear students. This is very simple. You know that we know R of union P, this is equal to N of R plus N of P. N of R plus N of P minus N of R intersection P, like this. N of R union P, we know this is 24. N of R is 20 plus 17 minus N of R intersection P, like this. 20 plus 17, 37. Now N of R intersection P is equal to 37 minus 24, like this. 7 minus 4, 3. 3 minus 2, 1. Therefore, N of R intersection P is equal to how many students forgotten both is nothing but 13 students had forgotten this. Okay, such a very beautiful problem this. Now see this particular problem, if x is equal to 8 power n minus 7n minus 1, where n belongs to natural numbers, y is equal to 49 n minus 1 or something like this. Let us see that. Okay, then find the relation between x and y. Let x is equal to, my dear students, if we take in x 8 power n, if I take n is equal to 1, then it becomes 8 minus 7 into 1 minus 1. That is 8 minus 8 equal to 0. Right? When n is 1, we have here one element like this. When n is equal to 2, if I take 8 square minus 7 into 2 minus 1, 64 minus 15. 64 minus 15, how much, my dear students? This is now 49, like this. 64 minus 15, 14 minus 5, 9, and fine. This is 5 minus 1. Like now we take n is equal to 3. 8 cube minus 7 into 3 minus 1. Now here like this, right? Okay, this is what for n equal to 1 you have what? 0, and n is 2 means 49, n is 3 means 8 cube. 64 into 8, you have 8 4s 32, 8 6s 48 plus 3 51. 512 minus 21 minus 1 22, like this, right? This is what you have here. 512 minus 22 0. Okay, 11 minus 2 9, 490. This is equal to 490 you have here, like this, right? Wonderful. Now when n is equal to 4 you take like this. 8 power 4 minus 7 into 4 minus 1, like this. Now 512 into, right, 8. 8 power 4, 8 cube is 512. 512 into 4, 8 2 16, 8 1s 8 plus 1 9, 8 5s 40, 4096. 4096 minus 29, like this. Right, my dear students? 7 4s 28 minus 1. Wonderful. That's what we are going to get. 4096 minus 29. This is now 16 minus 9. 7 you are going to get. 16 minus 9. 7 minus 2. Okay. 5 4057. Something you will be getting like this. Now see, my dear students, so on like this. X we have the elements as something like 0, 49, 490 and 4057, so on like this, right? And y, let us take the elements of y. Y is nothing but 49 times of n minus 1. If I take n is equal to 1 here, like this, you take n is equal to 1, y elements what I am going to get? 49 into 1 minus 1, that is 0. Okay, 0. When n is equal to 2, what I am going to get? 49 into 2 minus 1, 49 into 1, that is 49. When n is equal to 3, 49 into 3 minus 1, 49 into 3 minus 1 become 2, that is 98 you are going to get. When n is equal to 4, 49 into, you are going to get right? 4 minus 1, 49 into 3, like this, right? That become what you will be getting, 8 plus 9, 147, like this. That means it is having, y is having the elements, so something like 0, 49, 98, 147, so on, like this. That means I think x all its elements, okay, so on 490 also you will be having here, like this, right? And that means x elements all are present in y. That means x is subset of y is the correct relation you are going to get from this, because all the elements of x will be part of this. As you continue this, you will have up to infinity, all these elements will be present in this. That's why x is subset of y may be the correct one. Here this is 4067, 4067 is divisible by 49. Therefore, these are all elements are part of this. X is subset of y. I think this is what the correct answer, like that, right? Now see, my dear students, this ninth problem, if x is a finite set, at P of x denote the set of all subsets of x, and n of x denote the number of elements in x. If two finite subsets A and B satisfying the relation, what is the relation they are satisfying? N of P of A. N of P of A is equal to N of P of B. N of P of A equal to N of P of B plus 15. This is what? Okay, number of elements in the power set is nothing but 2 power n of A. This is equal to number of elements in the power set of B is equal to 2 power n of B plus 15, like this. Now 2 power n of A minus 2 power n of B is equal to 15. Now their difference we have to get it as 15. Then what are the elements we are going to have? I think 2 power 4 minus 2 power 0 if I take. This is 15, like 16 minus 1, that is 15. That means n of A is equal to 4 and n of B is equal to 0. That means B is an empty set, like, okay, A is having 4 elements and B is nothing but, I think so, this is an empty set. In this way, this can be answered very nicely, right? Such a beautiful way this problem can be answered. Now we have another problem. Let R be the set of points inside a rectangle of sides A and B, A comma B greater than 1, with two sides along the positive direction of x-axis and y-axis, and C be the set of points inside a unit circle centered at origin. Then, okay, they have given the options here. The options, option A is given that R is equal to set of all points x comma y, right? And such that 0 lesser than or equal to x lesser than or equal to A, and 0 lesser than or equal to y lesser than or equal to B. This is option A, which is correct. They are asking here. R is equal to set of all points x comma y such that 0 less than x less than A, 0 less than y less than B, like this. C is nothing but, okay, C, okay, center, that is nothing but set of all points x comma y such that x square plus y square is greater than 1, like this. Next, D option, R union C is equal to R. You see, my dear students, actually this is in the coordinate plane. If we, okay, write this, we have that this is what origin, and they given that set A is on x-axis, A is greater than 1, and we have here B, this is also greater than 1. By joining this, you will get this rectangle, and they told that the points inside the rectangle, that means okay, x value we are going to take, x value is nothing but 0 less than x less than A, 0 less than x less than, x value is nothing but 0 less than x less than, because they are inside, and y value is nothing but this y value, 0 less than y less than B is only corrected. Okay, if you include means the boundary also is included, equal to, if you keep it equal to, then boundary also included. Therefore, the second option is correct for this. And C is a point they given that x comma y such that x square plus y square greater than 1. Greater than 1 means what? This is the unit circle. Okay, x square, this equation is nothing but x square plus y square is equal to 1. Okay, the points inside will be satisfied by x square plus y square less than 1, and outside points, any points, those will be satisfied by x square plus y square greater than 1. Now here the correct option is 0 less than x less than a, 0 less than y less than b. I think this is correct. You can, okay, take this option as correct one like that.